The November rain had finally stopped when Hauptmann Friedrich Weber stepped into the dimly lit testing facility at the Kummersdorf weapons proving ground, south of Berlin. The date was March 15th, 1943, and what lay on the examination table before him would fundamentally alter his understanding of infantry anti-tank warfare. It was an American rocket launcher, captured just weeks earlier in Tunisia, still bearing the sand and grime of North African combat. Weber had spent 5 years developing Germany's answer to the tank threat. He'd witnessed the evolution from anti-tank rifles to shaped charge grenades, from the cumbersome Panzerbüchse 39 to the newly fielded Panzerfaust 30. He believed Germany led the world in portable anti-tank weaponry, but as he lifted the surprisingly simple American tube, weighing barely 13 pounds, everything he thought he knew about infantry weapons design was about to be challenged. The weapon had no markings, identifying it as revolutionary. Just a smooth steel tube, roughly 5 feet long, with a wooden shoulder stock, trigger assembly, and basic iron sights. American soldiers called it the Bazooka, after some comedian's musical instrument. The name sounded ridiculous. The weapon, however, was anything but. German infantry had been reporting encounters with this mysterious American rocket weapon since early February. Panzer crews described watching their comrades' tanks explode from impacts that came not from anti-tank guns, but from individual soldiers firing from concealed positions. Intelligence officers initially dismissed these reports as exaggeration or misidentification. Tanks didn't get destroyed by handheld weapons. That was impossible, but here it was. Real, functional, captured from American forces during the confused fighting near Kasserine Pass. And as Weber began his examination, assisted by Dr. Heinrich Langweiler from the Weapons Development Office, they discovered something that would send shockwaves through German military planning. The Americans had solved a problem that had frustrated German engineers for years. They had created a truly practical infantry anti-tank weapon, not a cumbersome rifle that could barely penetrate armor, not a suicidal magnetic charge requiring soldiers to approach within arm's reach of enemy tanks, but a genuine standoff weapon that could be fired from a safe distance, with devastating effect. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Weber's first action was to completely disassemble the captured launcher. What he found surprised him. The weapon was almost insultingly simple. A tube. A battery-powered ignition system. Sights graduated for 100, 200, 300, and 400 yards. That was essentially it. No complex machinery. No precision machined components. Nothing that required advanced manufacturing capability. The rocket itself told an even more interesting story. At 2.36 inches in diameter, the American projectile was smaller than anything Germany was developing. Yet, according to intelligence reports, it could penetrate up to 5 inches of armor plate. The secret lay in the warhead design, a shaped charge that concentrated explosive force into a superheated jet capable of burning through steel. Germany knew about shaped charges. They'd been experimenting with the technology for years. But the Americans had weaponized it in a package that even minimally trained infantry could effectively employ. Not the technology itself, but the practical application. Dr. Langweiler spent 3 days examining the rocket motor. The propellant burned completely within the launch tube, leaving the operator safe from backblast. The fin-stabilized projectile flew straight and predictable. Everything about the design prioritized reliability and ease of use over theoretical performance. This is not a weapon designed by engineers trying to impress other engineers, Langweiler observed, carefully measuring the rocket's dimensions. This is a weapon designed by people who understand combat. The comment struck Weber deeply. He thought about the Panzerfaust 30 they'd just begun issuing to infantry units. Single shot, 30-meter range, requiring soldiers to get dangerously close to enemy tanks before firing. Effective, yes, but also terrifying to use. German soldiers called Panzerfaust operations tank hunting, and with good reason. The hunt often ended badly for the hunter. This American weapon changed the equation entirely. A two-man crew could engage armor from 300 yards away. That was beyond the effective range of tank machine guns. That meant infantry could destroy tanks without exposing themselves to immediate retaliation. That meant the tactical balance between armor and infantry had fundamentally shifted. On March 18th, Weber authorized live-fire testing. The question wasn't whether the bazooka worked. Intelligence reports and the weapon's obvious quality confirmed that. The question was how well it worked, and whether Germany could produce something similar. They erected a captured British Valentine tank at the Kummersdorf range, positioning it at various distances. German soldiers who'd been trained on Panzerfaust operations were given minimal instruction on the American weapon. 20 minutes of familiarization, basic sight picture explanation, simple trigger discipline, nothing more. The first shot was fired from 150 yards. The operator, a corporal named Ernst Hoffmann, who'd destroyed 2 Soviet tanks with magnetic charges on the Eastern Front, steadied the tube on his shoulder. His assistant loader, Private Klaus Richter, inserted the rocket and tapped Hoffmann's helmet to signal readiness. Hoffmann squeezed the trigger. The battery sent current to the rocket igniter. There was a sharp crack, a whoosh of propellant, and the rocket streaked toward the target. 2 seconds later, the Valentine's frontal armor erupted in a shower of molten steel. The shaped charge had punched clean through, exactly as designed. Mein Gott, Hoffmann whispered, lowering the launcher. That was from 150 yards. I could have done that from cover. I wouldn't have even been in danger. They fired 17 more rockets that day, 16 hits, 1 miss, attributed to operator error when the firer jerked the trigger. Every hit penetrated the tank's armor. Every hit would have killed or disabled the crew. The weapon's effectiveness was undeniable, but it was the ease of use that truly shocked the German observers. Hoffmann, who'd trained for weeks to master Panzerfaust operations, became proficient with the bazooka in less than an hour. Richter, who'd never operated any anti-tank weapon, could load and prepare rockets with minimal supervision. The Americans have democratized tank killing, Weber wrote in his preliminary report. They have created a weapon that turns ordinary infantry into tank destroyers. This represents a fundamental shift in armored warfare doctrine. The report reached Berlin within days. Response was immediate. The Heereswaffenamt, Germany's Army Weapons Office, directed Weber to accelerate evaluation. They wanted to know everything: effective range, penetration capability, reliability, manufacturing requirements, training time, everything. But they also wanted something else. They wanted Germany to produce its own version, not a copy, an improvement, something that would restore Germany's perceived technological edge. Weber understood the assignment. But as he continued examining the American weapon, he began to realize something troubling. The bazooka's greatest strength wasn't its technology, it was its philosophy. The Americans had designed a weapon for mass production, for minimal training, for battlefield conditions where nothing worked perfectly, and soldiers needed tools that worked well enough. Germany's approach had been different. The Panzerfaust represented German engineering philosophy, clever, innovative, cost-effective to manufacture, but limited in capability and requiring courage that bordered on suicidal to employ effectively. It was a weapon born of resource constraints and tactical desperation. The bazooka came from abundance. American industry could afford to put batteries in weapons, could afford to make reusable launchers, could afford to train soldiers extensively, could afford to develop rockets that flew straight and hit hard from distances that kept infantry safe. On March 23rd, Weber received orders to meet with General der Panzertruppe Heinrich von Stülpnagel to discuss German response options. The meeting took place at the Weapon Development Office in Berlin, in a conference room filled with engineers, ordnance, officers, and representatives from HASAG, the company currently producing Panzerfaust launchers. Von Stülpnagel began. The Americans have presented us with both a problem and an opportunity. The problem is obvious. They have armed their infantry with a weapon that threatens our armoured superiority. The opportunity is equally obvious. We can learn from their design and produce something even better. Weber stood to present his findings. He'd prepared detailed drawings, performance data, and tactical assessments. But he began with a simple demonstration. He placed the captured bazooka on the conference table next to a Panzerfaust 30. These weapons represent two completely different philosophies, he said. The Panzerfaust is designed for close-range ambush, maximum 30 meters, single shot, disposable. It requires soldiers to position themselves near enemy tanks, fire, and hope they hit before the tank's supporting infantry kills them. It is effective within its limitations, but those limitations are severe. He picked up the bazooka. This weapon engages from 300 yards. It is reusable. Two-man crew can fire 4 to 6 rockets per minute. The operator remains at a distance where tank machine guns are largely ineffective. It can be aimed and fired from prone, kneeling, or standing positions. Training time is measured in hours, not days. The room was silent. Everyone understood the implications. The Americans have created a weapon that neutralizes our tactical advantages, Weber continued. German armor relies on shock and mobility. We close with enemy positions quickly, using speed and firepower to overwhelm defenders before they can organize effective resistance. This weapon gives ordinary infantry the ability to stop our tanks from positions we cannot easily suppress. One of the Hassag representatives, an engineer named Dietrich Schwarz, raised his hand. Surely our own weapons can be improved to match this capability? Weber shook his head. The Panzerfaust cannot be scaled up to longer ranges without completely redesigning it. The recoilless principle that makes it cheap and portable also limits its effective range. To match the bazooka's performance, we would need to abandon the Panzerfaust concept entirely and develop something new. Then that is what we shall do, von Stülpnagel declared. Hauptmann Weber, you will lead a development team. Your objective is to create a German rocket launcher superior to the American design. I want prototypes within 8 weeks, production within 6 months. We will show the Americans that German engineering remains supreme. The room erupted in discussion. Questions flew. Could they enlarge the rocket diameter for better penetration? Could they improve range beyond the American weapon? Could they manufacture it with available materials given resource shortages? Weber let the discussion continue for several minutes before raising his hand for silence. Herr General, with respect, I must point out certain realities we cannot ignore. Von Stülpnagel's expression hardened. He didn't appreciate pessimism, but he gestured for Weber to continue. The American weapon uses batteries for ignition, batteries that must function in extreme cold, extreme heat, mud, rain, and combat conditions. Our battery production is already stretched, supporting existing weapons and communications equipment. Additionally, the bazooka uses a specific steel alloy for the launch tube that must withstand repeated firings without warping or failing. Our steel production prioritizes armor plate and tank components. Weber paused, then continued. Most importantly, the Americans have designed this weapon for their manufacturing capabilities and tactical doctrine. They have extensive infantry support. They have reliable supply chains. They have the luxury of training soldiers thoroughly. We face different constraints, different tactical requirements. Simply copying their design may not serve our needs. Dr. Langweiler stood, supporting Weber's assessment. I have examined the American rocket motor extensively. The propellant formulation uses materials we currently prioritize for other applications. The shaped charge requires precision manufacturing that will compete with artillery shell production, and the electrical firing system, while reliable in American hands, may prove problematic in our supply chain. Are you suggesting we cannot build this weapon? Von Stülpnagel asked, his voice carrying an edge of frustration. No, Herr General, Weber replied. I am suggesting we should not simply copy it. We should instead understand what makes it effective, then design a German solution that achieves similar results while accounting for our specific circumstances. The discussion that followed would shape German anti-tank weapons development for the rest of the war. The decision was made to pursue two parallel paths. First, continue improving the Panzerfaust for situations where its simplicity and low cost justified its tactical limitations. Second, develop a new rocket launcher that incorporated lessons from the captured Bazooka while addressing German manufacturing and tactical realities. The new weapon would be called the Panzerbüchse, or rocket anti-armor rifle. It would become known to German soldiers and Allied troops alike as the Panzerschreck, the tank terror. But as development began, Weber couldn't shake a troubling realization. The captured Bazooka represented more than just a clever weapon design. It represented an approach to warfare that Germany, with its shrinking resources and increasingly desperate tactical situation, could no longer afford to emulate. The Americans could build thousands of bazookas because they had the industrial capacity and raw materials. They could train soldiers extensively because they had time and training facilities behind secure lines. They could develop sophisticated weapons because they weren't fighting for survival on multiple fronts while being bombed around the clock. Germany faced different realities. Every weapon had to be producible with increasingly scarce resources. Every tactical system had to account for shrinking manpower and compressed training timelines. Every engineering decision had to balance ideal performance against practical constraints. On April 2nd, 1943, the first German Panzerschreck prototype was tested at Kummersdorf. It fired an 88mm rocket, significantly larger than the American 60mm design. The larger warhead provided superior armor penetration, exactly as German specifications demanded. But the weapon was heavier than the bazooka. 11 kilograms empty versus the American weapon's 6 kilograms. The rocket motor burned incompletely in the tube, creating a dangerous backblast that forced operators to wear protective gear, including face shields and heavy gloves. The accuracy was inferior to the American design, with significant dispersion beyond 150 meters. Most troublingly, the electrical firing system proved unreliable. German batteries, manufactured to different specifications than American cells, provided inconsistent current. In cold weather testing, failure rates exceeded 30%. The solution was to develop a spring-loaded magneto-generator, adding weight and complexity. Weber watched the testing with mixed feelings. Yes, the Panzerschreck could destroy tanks. Yes, it provided longer range than the Panzerfaust. But it wasn't the elegant solution he'd hoped to achieve. It was a compromise, forced by circumstances and constraints that the Americans simply didn't face. "It works," Dr. Langweiler observed, watching another successful penetration test. "Not perfectly, but adequately. In warfare, adequate performance delivered now is worth more than perfect performance delivered too late." Weber nodded. That had become Germany's mantra. Good enough, soon enough. The Panzerschreck would enter production not because it was better than the bazooka, but because Germany needed something comparable and needed it immediately. Meanwhile, Panzerfaust development continued along its own path. The single-shot disposable launcher remained attractive for its simplicity and low production cost. Weber's team developed the Panzerfaust 60, with double the range of the original 30-meter variant. Then the Panzerfaust 100, pushing effective engagement to 100 meters. But even the improved Panzerfaust couldn't match the bazooka's standoff capability. That was simply the nature of the technology. Recoilless launchers were limited by physics. To achieve longer range, they needed larger propellant charges, which created more backblast, which required heavier tubes to contain safely. At some point, the weapon became too heavy and cumbersome for individual soldiers to carry effectively. The bazooka's rocket motor design, with all propellant burning in the tube, allowed for lighter construction and longer practical range, but it required manufacturing sophistication and materials that Germany increasingly lacked. By summer of 1943, both German weapons were entering production. The Panzerschreck went to specialized anti-tank units. The Panzerfaust went to regular infantry as a last-ditch defense weapon. Both filled necessary roles. Neither achieved the elegant simplicity of the American design that had inspired them. Weber received a new assignment in August. He was to write a comprehensive analysis comparing German anti-tank weapons to Allied equivalents. The report would inform future development priorities and tactical doctrine. He spent 3 months on the project, examining captured weapons, interviewing soldiers, analyzing combat reports. His conclusions, submitted in November 1943, would remain classified until after the war. But the key findings were brutally honest. The American bazooka represents a philosophical approach to weapons development that Germany can admire but cannot emulate. Weber wrote, "It is a product of abundant resources, sophisticated manufacturing, and tactical doctrine that prioritizes soldier safety and training quality. Germany faces opposite constraints. We must design weapons for resource scarcity, simplified manufacturing, and minimal training time. The Panzerfaust succeeds within its limitations because those limitations are acceptable given our circumstances. A 30 to 60 meter weapon is adequate for defensive ambush tactics, which increasingly characterize German operations. The disposable nature eliminates logistical burdens. The simple design enables mass production despite material shortages. The Panzerschreck provides needed standoff capability, but at costs that may not be sustainable. Each launcher requires resources equivalent to multiple Panzerfausts. Training and maintenance demands exceed what depleted infantry units can provide. Effectiveness is unquestionable, but efficiency remains problematic. The report included a section that would prove prophetic. American infantry weapons development follows consistent patterns. Reliability over sophistication. Maintainability over optimization. Adequate performance available to all soldiers over superior performance available to few. This approach reflects industrial abundance and logistical excellence. Germany cannot compete on these terms. We must instead focus on weapons that work despite constraints, not because constraints have been eliminated. As 1943 turned into 1944, Weber's analysis proved increasingly accurate. Panzerfaust production reached massive scales. By war's end, over 6 million would be manufactured. Simple, cheap, somewhat effective. Germany's answer to overwhelming Allied armour superiority wasn't technological excellence. It was desperate mass production of adequate weapons. The Panzerschreck, meanwhile, struggled with production bottlenecks and supply difficulties. Total production barely exceeded 290,000 units, with rocket availability often limiting employment. When it worked, it was deadly. But it worked less consistently than planned. Weber never got to see how American infantry adapted their tactics once Panzerschrecks appeared in numbers. He was killed in an air raid on Berlin in March 1944, 1 year and 3 days after first examining the captured bazooka that had inspired Germany's response. His final report, recovered from his office after the raid, contained a handwritten note in the margin of the section comparing American and German approaches. They build weapons for the war they are winning. We build weapons for the war we are losing. The difference shows in every design choice, every production decision, every tactical employment. The captured bazooka taught us what is possible with abundant resources. Our Panzerfaust and Panzerschreck teach us what is necessary with scarce ones. History will judge which approach was wiser, but I suspect the judgment is already clear. The spring thaw of 1944 brought more than mud to the Eastern Front. It brought a new reality that German soldiers described in letters home with barely concealed despair. American weapons were appearing in Soviet hands through Lend-Lease, and among them were bazookas. The irony wasn't lost on veterans who'd fought at Kursk. Germany had captured the weapon from Americans in Tunisia, reverse-engineered it into the Panzerschreck, and now faced the original American design coming at them from the east. Lieutenant Hans Dietrich commanded a panzer company in the 4th Panzer Division, operating near Kovel in Ukraine. His diary entries from April 1944 provide stark insight into how the proliferation of anti-tank rocket weapons was changing armoured warfare fundamentally. April 8th. Lost to Panthers today. Not to Soviet anti-tank guns, which we can spot and suppress. Not to their tanks, which we outmatch in direct combat, but to individual soldiers with rocket launchers, firing from concealed positions in tree lines. They wait until we pass, then strike our vulnerable rear armor. By the time we identify the threat and return fire, they've displaced. This is not warfare. This is assassination. April 12th. Received intelligence briefing on American Bazooka, now in Soviet hands. Effective range 300 meters. Penetration sufficient to destroy any German tank from sides or rear. Simple enough that minimally trained conscripts can employ it effectively. Our infantry now faces similar weapons from American troops in Italy. The tank, once the queen of the battlefield, has become a target. Dietrich's observations weren't unique. All across both fronts, German commanders reported the same phenomenon. The tactical dominance armor had enjoyed early in the war was evaporating. Not because Allied tanks had gotten dramatically better, though they had improved, but because infantry anti-tank capabilities had multiplied exponentially. The German response revealed the depth of their resource crisis. They couldn't match Allied production of sophisticated rocket weapons. What they could do was flood frontline units with Panzerfausts and hope that volume compensated for capability limitations. By mid-1944, German infantry doctrine had evolved into what veterans called Panzerfaust tactics. Every squad received multiple single-shot launchers. Soldiers were instructed to position themselves in buildings, tree lines, and foxholes along likely armor approach routes. Wait until enemy tanks closed to within 60 meters. Fire. Discard the empty tube. Retreat if possible. It was effective in the same way that throwing sandbags at a flood is effective. It might slow things down temporarily, but it wasn't going to stop the inevitable. Oberfeldwebel Kurt Mansfeld, a veteran infantry NCO, trained replacement troops at a facility near Munich throughout late 1944. His recollections, recorded in post-war interviews, captured the desperation underlying German tactics. We'd get boys, 17 and 18 years old, with maybe 6 weeks of basic training. We had 3 days to teach them infantry skills that used to take 3 months. Tank defense was the priority. We'd hand them a Panzerfaust, explain the basics in an hour, let them fire 1 practice shot if we had practice ammunition, which often we didn't. Then we'd send them to the front. I'd tell them the truth. This weapon will let you destroy any Allied tank, once, from close range. If you miss, you die. If you hit but the tank has supporting infantry, you probably die anyway. Use it from cover. Fire and run. That's all you can do. Some of them would ask about the Panzerschreck, the longer-range weapon they'd heard about. I'd tell them those went to specialized units. Regular infantry got Panzerfausts. Get close, shoot straight, hope for the best. The contrast with American training methods couldn't have been more stark. American infantry received weeks of weapons familiarization. They practiced with live ammunition until proficiency was second nature. They learned combined arms tactics that integrated bazookas with supporting weapons. They understood how to maneuver, how to coordinate, how to maximize their weapons' capabilities while minimizing exposure. German training had devolved into abbreviated instruction periods focused on immediate survival. Learn enough to maybe kill 1 tank before dying. That was the realistic expectation. Meanwhile, American bazooka tactics continued evolving based on combat experience. By late 1944, U.S. Army doctrine included sophisticated employment techniques that German observers could only envy from captured training manuals. American infantry used bazookas in coordinated teams. 1 team would fire to suppress or disable a tank. Supporting teams would engage any infantry escort. Machine guns would pin down enemy forces trying to respond. Mortars would drop smoke to cover displacement after firing. The entire system worked together, each element supporting the others. German tactics, by necessity, were more primitive. Individual soldiers with Panzerfausts, acting largely independently, hoping to catch tanks in vulnerable moments. coordination was difficult when units were under strength, undertrained, and operating with minimal support. Effectiveness depended more on courage and luck than on systematic tactical excellence. In November 1944, a remarkable document reached German High Command. It was a captured American training manual titled Bazooka Team Tactics in European Theatre Operations. The manual had been recovered from a destroyed command post near Aachen. Someone in intelligence thought to translate it and distribute selected portions to German units. Reading it must have been demoralizing. The manual described employment techniques that German forces simply couldn't replicate. It assumed abundant ammunition, regular resupply, supporting arms, trained crews, and operational flexibility. It treated bazooka teams as integral parts of combined arms operations, not as desperate last-resort defenders. One section particularly highlighted the philosophical gap between American and German approaches. Under bazooka team composition and training standards, the manual specified each bazooka team consists of 2 soldiers, gunner and assistant gunner. Minimum training requirement: 40 hours classroom instruction, 80 hours practical training, qualification on known distance range with minimum score of 70% hits at ranges from 50 to 200 yards. Teams must demonstrate proficiency in target identification, range estimation, deflection shooting, coordination with supporting elements, displacement after firing, ammunition resupply procedures. German Panzerfaust instruction, by comparison, was measured in hours, not weeks. There were no qualification standards because there was no time for qualification courses. Soldiers received basic instruction, perhaps one practice shot, then went to combat. They learned proficiency through experience, assuming they survived long enough to gain experience. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The technological evolution of both weapons systems during 1944 and 1945 revealed different priorities driven by different circumstances. American bazooka development focused on incremental improvements, better rockets with improved penetration, refined sights for enhanced accuracy, design modifications to reduce weight while maintaining effectiveness. German development followed more desperate paths. The Panzerfaust 150, introduced in late 1944, pushed effective range to 150 meters, double the original design. But achieving this required a heavier warhead and larger propellant charge, making the weapon more cumbersome and producing greater backblast that endangered operators. The Panzerschreck received modifications addressing its most glaring deficiency, the dangerous rocket exhaust that initially forced operators to wear gas masks and protective gear. The RPZB-54 variant, introduced in early 1944, incorporated a blast shield protecting the firer's face. Later versions used improved rocket motors that burned more completely in the tube, reducing backblast somewhat. But these improvements couldn't overcome fundamental limitations. The Panzerschreck remained heavier than the bazooka, required more extensive training, needed more logistical support, was harder to manufacture and maintain. In every practical measure except raw penetration power, the German weapon was inferior to its American inspiration. The ultimate irony emerged in combat reports from both fronts during the final year of the war. American forces, encountering Panzerschreck-equipped German units, generally handled them effectively through combined arms tactics and superior fire support. German forces, facing bazooka-equipped American infantry, struggled consistently because they lacked the coordination and support necessary to suppress or neutralize enemy anti-tank teams. The weapon mattered less than the system employing it. Americans had built an entire tactical doctrine around the bazooka, supported by training, logistics, and combined arms coordination. Germans had added the Panzerschreck to existing units without fundamentally reorganizing how those units operated. Predictably, the American approach proved more effective. Private First Class Robert Hauptmann, an American infantryman in the 1st Infantry Division, wrote home in December 1944, describing an engagement near Aachen that illustrated these tactical differences. We were advancing through this bombed-out village when 3 German tanks appeared. Our Bazooka team, Corporal Davis and Private Williams, took position in a building foundation. Davis spotted the lead tank at maybe 200 yards. Williams loaded while Davis aimed. First shot hit the tank's track, immobilized it. Supporting fire from our machine guns kept German infantry pinned down. Mortars dropped smoke. Davis and Williams displaced to another position while the German crew was still figuring out what happened. Second tank tried to back up, exposed its side armor. Davis hit it from a different angle, about 150 yards. That one brewed up proper. Crew bailed out. Third tank just reversed out of there fast. We didn't pursue. Called up tank destroyers to secure the area. Whole engagement maybe 10 minutes. We lost nobody. Germans lost 2 tanks, and probably a dozen infantry who got caught by our machine gun fire. The neat thing is, this is just how we trained. Everyone knew their job. Bazooka team engaged armor. Machine guns suppressed infantry. Mortars provided smoke. Leadership coordinated the whole thing. It worked exactly like it was supposed to work. Not luck. System. Compare that to a German account from Obergefreiter Paul Steinbach, fighting near the same time in the Hürtgen forest. American tanks approached our position. We had 2 Panzerfausts in the platoon, 30-meter range. To use them, someone had to let the tanks get within 30 meters, basically point-blank range. He crawled forward, got within range, fired. Missed. Tank traversed its gun toward the muzzle flash. Machine gun fire cut Richter down before he could retreat. Schmidt tried next with our second Panzerfaust. He got closer, nearly 20 meters. Hit the tank's frontal armor. Warhead detonated but didn't penetrate. Tank backed up while supporting American infantry advanced. We had no machine gun support. Our MG-42 had been lost 2 days prior. No mortars, no artillery support. We withdrew under fire. Lost 5 men. Tank was undamaged. These contrasting accounts encapsulated the fundamental difference between American and German anti-tank operations by late war. Americans employed sophisticated weapons within sophisticated tactical systems. Germans employed adequate weapons within degraded tactical systems. The weapons mattered less than the context in which they were used. The production statistics told their own story about divergent approaches and capabilities. By war's end, the United States had manufactured approximately 476,000 bazooka launchers of all variants. Germany produced roughly 6.8 million Panzerfausts, but only 290,000 Panzerschrecks. The disparity revealed strategic realities. America could afford to equip infantry extensively with reusable, sophisticated weapons. Germany had to resort to mass-producing disposable weapons that required minimal resources per unit, quality versus quantity, driven not by choice but by necessity. But even the quantity approach had limits. A 6 million Panzerfaust sounds impressive until you consider that Germany fielded millions of soldiers across multiple fronts. Many units received only a handful of launchers, some received none. The weapons were never abundant enough to truly saturate frontline forces with anti-tank capability. American forces, by contrast, typically had at least 1 bazooka team per infantry platoon, often more. Every company had multiple teams. Battalion weapons platoons included dedicated bazooka sections. The weapons were available in numbers that made them tactically reliable rather than tactically desperate. Dr. Wilhelm Mertens, a German weapons analyst who survived the war and worked for U.S. Army intelligence during the occupation, provided perspective in a 1947 assessment. The American bazooka was not technologically superior to German equivalents in terms of pure performance metrics. Our Panzerschreck had better penetration. Our Panzerfaust was simpler and cheaper. But the Americans understood something we failed to grasp until too late. Individual weapon performance matters far less than systematic employment. They built adequate weapons and used them excellently. We built excellent weapons and used them adequately at best. The bazooka succeeded because it was part of a comprehensive approach to infantry anti-tank warfare. Training, doctrine, logistics, combined arms integration. Every element supported every other element. The weapon itself was merely one component of a functional system. Germany's approach was reactive and fragmented. We captured the bazooka and said, "We must build something like this." But we didn't ask the deeper question: how do the Americans make this weapon? Effective in combat? We copied the hardware without understanding the software, the organizational and doctrinal framework that made the hardware relevant. This systematic difference extended beyond just anti-tank weapons. It characterized the entire approach to infantry equipment and tactics. American forces emphasized standardization, thorough training, logistical depth, and combined arms coordination. German forces, especially late in the war, emphasized improvisation, abbreviated training, logistical desperation, and isolated unit actions. Neither approach was inherently superior in abstract terms, but in the context of industrial total war, the American systematic approach scaled better. It could be taught, replicated, and sustained across millions of soldiers. The German approach relied more on individual initiative and unit-level adaptation, which worked brilliantly with veteran formations but degraded rapidly as casualties mounted and veteran units were destroyed. The captured bazooka that Friedrich Weber examined in March 1943 represented more than just a weapon. It represented a philosophy of warfare that Germany, by 1943, could no longer emulate: the ability to thoroughly train soldiers, the luxury of abundant ammunition for practice, the industrial capacity to manufacture sophisticated weapons in massive quantities, the logistical capability to supply frontline units reliably. All of these advantages, which Americans took for granted, were increasingly beyond German reach. By 1945, the gap had become unbridgeable. American infantry received new improved weapons regularly. Training continued even for frontline units during rest periods. Ammunition was sufficiently abundant that soldiers could fire weapons to familiarization without worrying about conservation. Replacement equipment arrived whenever needed. German infantry made do with whatever they had. Training had been reduced to the absolute minimum. Ammunition was carefully rationed. Replacement equipment was often scavenged from casualties or captured from enemies. The decline was visible in every aspect of operations. An American intelligence report from March 1945, analyzing captured German documents and prisoner interrogations, concluded, "German infantry anti-tank capabilities have degraded to crisis levels despite superficially impressive weapon types. Panzerfaust availability remains adequate, but trained operators are increasingly scarce. Panzerschreck employment has declined due to ammunition shortages and crew losses. German infantry formations now rely primarily on hope that American armor will expose vulnerabilities that untrained soldiers with limited weapons can exploit. This represents complete failure of systematic anti-tank defense." The report was accurate, but perhaps lacked full understanding of German circumstances. It wasn't that German soldiers had given up. It was that the systematic approach to warfare, which both sides had embraced in 1939 and 1940, had completely broken down for Germany by 1945. What remained was courage, desperation, and inadequate tools to accomplish impossible missions. In the war's final weeks, there were instances of German soldiers using captured bazookas alongside Panzerfausts and Panzerschrecks, creating makeshift arsenals of Allied and German weapons. The ironies were lost on nobody. They were fighting with weapons copied from enemies' designs, alongside weapons captured from those same enemies, in a war that was obviously lost. A photograph exists from April 1945, taken by an American soldier near the Elbe River. It shows a destroyed German position with 3 different anti-tank weapons scattered among the rubble: a Panzerfaust 60, a Panzerschreck, and an American bazooka. The German defenders had used all 3 before being overrun. The image captured the desperation and chaos of the war's end better than any words could. The bazooka survived the war and continued serving with American forces through Korea and beyond. Improved variants, including the Super Bazooka, with its larger 89mm warhead, addressed the weapon's limitations while retaining its core strengths. The basic concept proved sound enough for decades of service. The Panzerfaust's legacy was different but perhaps more significant. The disposable, single-shot, recoilless anti-tank launcher concept influenced post-war weapon development worldwide. The Soviet RPG series, the American LAW, the Swedish AT-4, all descended conceptually from the Panzerfaust's pioneering design. In that sense, Germany's necessity-driven innovation had lasting impact. The Panzerschreck faded into history as a cautionary tale. It proved that copying successful enemy weapons without understanding the systematic context, enabling their success, produces mediocre results. The German version was heavier, less reliable, and harder to employ than its American inspiration, despite having superior armor penetration. Performance specifications matter less than operational effectiveness. Post-war analysis by military historians and weapons experts consistently reached similar conclusions. The bazooka's success stemmed not from technological superiority, but from systematic employment within a comprehensive tactical framework. Germany's inability to replicate that framework, rather than any inability to replicate the hardware, explained the differential effectiveness. In 1952, a U.S. Army study on anti-tank weapons development included an interesting footnote. Researchers had interviewed German engineers who'd worked on Panzerschreck development. One anonymous engineer provided a quote that ended up buried in an appendix. "We understood the bazooka's technical principles within days of examining the captured specimen. We replicated and supposedly improved those principles within months. But we never understood the most important thing. The Americans had designed a weapon for their army, their tactics, their logistics, their training system. We tried to design a German weapon using American concepts and produced something that fit neither our capabilities nor our needs. The Panzerfaust, born of our own requirements and constraints, was actually the more successful weapon for our circumstances." Looking back, the captured bazooka taught us the wrong lesson. We learned that Americans had created an effective infantry anti-tank weapon. What we should have learned was that Americans had created an effective system of infantry anti-tank warfare. The weapon was merely one element of that system. We copied the element while ignoring the system. That failure characterized much of our late-war weapons development. This insight, buried in an obscure appendix, captured the essential truth that Friedrich Weber had intuited back in March 1943. Weapons don't win wars in isolation. Systems win wars. Training wins wars. Logistics wins wars. Industrial capacity wins wars. The weapon is simply the tool through which these deeper advantages manifest. The American bazooka, with its practical 300-yard engagement range, represented American abundance applied to infantry anti-tank problems. The German Panzerfaust, with its desperate 30 to 100-meter range, represented German scarcity forcing tactical compromises. The Panzerschreck, attempting to bridge the gap, achieved neither the bazooka's systematic integration nor the Panzerfaust's efficient simplicity. By 1945, the range differential that German engineers had first noted in March 1943 had become symbolic of larger disparities. American soldiers could engage German tanks from 300 yards because American training, logistics, and combined arms doctrine enabled effective employment at that range. German soldiers had to close within 30 to 100 meters because German circumstances forced acceptance of those dangers. The weapons reflected the wider war. One side had options, resources, and systematic advantages. The other side had courage, desperation, and increasingly inadequate tools. The outcome was never in doubt once those fundamental imbalances became clear. In museums today, bazookas and Panzerfausts and Panzerschrecks sit side by side in display cases, equidistant from the wars they fought. Visitors see engineering artifacts, technological curiosities from a violent past. What's harder to display is the context those weapons operated in. The training systems, the logistical networks, the tactical doctrines, the industrial capacities, all the invisible factors that made some weapons effective and others merely dangerous. The captured bazooka that started this story, assuming it survived the war, probably ended up in a similar display case somewhere. A German engineering team's introduction to American approaches to infantry anti-tank warfare, a catalyst for German weapon development that never quite achieved its objectives. A reminder that copying hardware is simple compared to replicating the comprehensive systems that make hardware effective. 3 anti-tank weapons, 2 approaches to warfare, 1 lesson, learned too late by one side and never forgotten by the other. Systematic excellence defeats individual brilliance. Adequate weapons employed expertly beat superior weapons employed desperately, and in total war, industrial abundance and organizational depth matter more than engineering elegance. The morning rain had finally stopped when Friedrich Weber examined that captured bazooka in March 1943. He understood immediately that Germany faced a new challenge. What he couldn't have known was that the challenge wasn't technological, it was systematic. And by 1943, Germany had already lost the systematic war. The bazooka was simply the weapon that made that reality visible to those willing to see it. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.